Let's create AI weather app using Python and machine learning. We import Flask for the web framework, Pandas and NumPy for data handling, random first classifier as our ML model, and train_test_split for splitting data during training. This initializes the Flask application, so we can define routes and handle HTTP requests. We define a function to encapsulate all model training logic, keeping it clean and callable on app startup. We set a random seed for reproducibility and define how many synthetic training samples to generate. We generate 500 random values for each feature: temperature -10 to 45 degrees Celsius, humidity 10–100%, and wind speed 0 to 50 km/h. To simulate realistic weather data, we apply rule-based logic to assign a weather condition label to each sample: rainy if high humidity and low wind, sunny if mild temperature and low humidity, otherwise cloudy. We organize all generated features and labels into a Pandas data frame for easy manipulation and model training. We separate the data frame into input features, X, and the target label, Y, that the model will learn to predict. We create a random forest classifier with 100 trees and train it on the synthetic weather dataset. We return the trained model so it can be stored globally and reused for every prediction request. We call the training function once at app startup and store the trained model in a global variable ready to serve predictions. We define a dictionary to convert the model's numeric output 0, 1, 2 into human-readable weather condition labels with emojis. This route serves the homepage, rendering the HTML UI where users can input weather data. This route handles prediction requests sent as JSON from the front end via a post call. We pass the incoming JSON body and extract the 3 input values, converting them to floats for the model. We package the inputs into a 2D NumPy array, matching the shape the model expects for a single prediction. We run the prediction and map the numeric result to its readable weather label using our weather_map dictionary. We return the prediction as a JSON response with a success flag so the frontend can display it to the user. If anything goes wrong during parsing or prediction, we catch the error and return a JSON error response instead of crashing. This starts the Flask development server in debug mode, enabling live reloading and detailed error output during development. Now here is our index.html where I have designed the all-user interface. If you'd like access to this code, just send me a message on our Discord server.